In this video, we will be solving equations such as this one with double angles involved. So we will have to use these double angle identities to make the appropriate substitutions to solve the equation. Along the way, I'm going to be assuming that you have memorized the facts that are on the screen right now. If you have not memorized these facts yet, pause the video and memorize them right now. So, what is the double angle formula for the sine function? What's sine of 2x? Sine of 2x is 2 sine x cosine x. So I'm going to make that substitution. So the left side of the equation will become 2 sine x cosine x. And the right side of the equation stays what it is. Now I'm going to get 0 on one side and factor. So if I subtract this, then I have 2 sine x cosine x minus 2 sine x is equal to 0. Now I'm always on the lookout for common factors. So I see that I have 2 sine x right here, and I have 2 sine x right here. So I can pull the 2 sine x outside of parentheses, and that will leave behind cosine x minus 1 is equal to 0. Now we can use the zero product property and set each of these factors equal to 0. So if I set 2 sine x equal to 0, and I will set cosine x minus 1 equal to 0. Dividing both sides by 2, I'm going to get sine x equals 0. 0 divided by 2 is still 0. Adding 1 to both sides, I will get cosine x is equal to 1. So, sine of what angle is 0? We are talking about quadrantal angles right now. So think about it. This is 1 comma 0, and this is 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Now sine is the y value on the unit circle. So where is the y value 0? The y value is 0 here and here. So that gives me two solutions right now. So x is equal to 0 and pi. All right, now I will turn my attention to cosine x is equal to 1. Now, cosine is the x value on the unit circle. So where is the x value equal to 1? Boom, that x value is equal to 1. And that's the only one. So that is angle 0, which we already have. So that doesn't actually give us any additional solutions. So this is the final answer then for problem number 6. For problem number 7, again I see that we have a double angle happening, cosine of 2x. So let's look at the double angle formulas. Notice that we have actually 3 different formulas for cosine of 2x. And so we can pick the one that we want to use depending on if we want cosine and sine, we'll do this one. If we want just cosine, we'll choose the middle one. If we want just sine, we'll do the bottom one. And it's going to depend on the rest of the equation. So on the left side of the equation, everything is in cosine. So I'm going to pick the version of the formula that has everything in cosine, the middle one. So 2 cosine squared x minus 1. So that's why I'm going to write 2 cosine squared x minus 1 in place of this. Now the rest of it is going to stay the same. So I have 2 cosine squared x plus cosine x. Now see how I have 2 cosine squared x on both sides? if we go subtracting that, minus 2 cosine squared x minus 2 cosine squared x, they cancel out completely. So that simplifies things a lot. So now I have cosine x is equal to negative 1. All right, well, where is cosine equal to negative 1? We are talking about quadrantal angles. Over here, we have 1 comma 0. Up here, we have 0 comma 1. Over here, we have negative 1 comma 0. And down here, we have 0 comma negative 1. Cosine is an x value on the unit circle. So where is the x value equal to negative 1? Boom. All right, here's where the x value is negative 1. So that is pi. So that's my only solution. X equals pi. Okay, let's keep going. Number 8, I see that we have sine of 2x. So again with the double angle situation. So I look and I see that sine of 2x is equal to 2 sine x cosine x. So I'm going to make that substitution right here. So I'm going to have 2 sine x cosine x. Now I'm just going to bring down the minus cosine x. Now I see that I have a common factor here and here. So I'm going to bring that common factor out. So here's my cosine x outside of the parentheses. That will leave behind 2 sine x minus 1. So now I will use my zero product property and set each factor equal to 0. Now over here, adding 1 to both sides, I have 2 sine x equals 1. Dividing both sides by 2, I have sine x is equal to 1/2. So now let's begin to solve this. Cosine of what angle is 0? Well, we are talking about quadrantal angles right now. So over here we have 1 comma 0. Up here is 0, 1. Over here this is negative 1, 0. And down here this is 0, negative 1. Cosine is an x value on the unit circle. So where's the x value equal to 0? Here and here. See how the x values are 0. So that gives us 2 solutions so far. We have x is equal to pi over 2 and 3 pi over 2. Now let's look at the other side. Sine of what angle is equal to 1/2? Now these are the values that we have memorized. So sine of pi over 6 is equal to 1/2. Now be careful. That is the reference angle. It's not the final answer. The reference angle is pi over 6. So I would draw a pi over 6 diagram to help us visualize what's happening. So I'm going to draw a bunch of pi over 6s. There are 4 angles that have a reference angle of pi over 6. All right, above and below the x-axis. The sine of any of these will be some type of a 1/2. But these two will be positive 1/2, and these two will be negative 1/2. Sine is a y value, so that's why it's positive up top and negative down below. For this particular problem, we want positive 1/2. So that's why these 2 angles will be the solutions. So in addition to the solutions we already have, we will add pi over 6 and 5 pi over 6. So these are the 4 solutions to problem number 8. All right, let's go ahead and take a look at problem number 9. All right, number 9 is a strange little problem, a lot of twists and turns. I find it very interesting, but watch closely. I have 2x and then I have 4x. I need to look at these as being the same type of variable. So I'm going to change the 4x a little bit. So look, I've got sine 2x, that's fine. And I'm sure we can all agree that 4x is the same thing as 2 times 2x. All right, can we all agree on that? 4x is 2 times 2x. Okay, so to understand what's about to happen next, I think it would be easiest if we do a temporary substitution. Okay, let's let 2x equal q. All right, this will help you wrap your mind around what I'm about to do next. Let's replace 2x with a single variable. So then this would become sine of q, all right, because 2x is temporarily going to be q. And this will become sine of 2q is equal to 0. Now, we can't have two different types of variable, q and 2q. So this is where we would do a double angle substitution using our double angle formula. So let's look at that. Sine of 2q will equal 2 sine q cosine q. So let's do that. All right, let's replace this with 2 sine q cosine q. All right, this is what we would do if everything was q. And now everything is all q. Everything is all good. In fact, let's go a little bit further with the q's. Let's see, what do we have here? I see that we have a common factor. We have sine q over here, and over here we have another sine q. So I'm going to take out that common factor. So that's going to leave me with sine q times 1 plus 2 cosine q. All right, that's going to leave me with this. All right, let's keep going. And but just in the back of your mind, remember we made this little temporary substitution that we're letting 2x equal q. But all of these q's are really little 2x's, but we'll put them back in at the end. We'll put 2x back in at the end. So if I continue to solve this equation, I would use my zero product property. So sine q is equal to 0. 1 plus 2 cosine q is equal to 0. Okay, that's done. So over here, subtracting 1 from both sides gives me 2 cosine q is equal to negative 1. Dividing both sides by 2, I have q, sorry, I don't have q yet. Dividing both sides by 2, I have cosine q is equal to negative 1/2. Okay, now we are ready to solve these for q. Where is q going to equal 0? Well, there we are talking about quadrantal angles. So I'll do my little quadrantal angle diagram. We have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine is a y value, so the question is, where will the y value equal 0? See, we have a y value of 0 here and here. So that gives me two solutions so far for q. All right, q will either equal pi. And you know what? I'm going to write all of these separately because of what's going to come next. So q will, let me go in order. I have these two angles, 0 and pi. So q will either equal 0 or q will equal pi. All right, that's what I have so far. Now, what about this one? Cosine of q is equal to negative 1/2. The cosine of what angle is negative 1/2? Forget the negative for a second. Cosine of what angle is 1/2? I'm hoping that you're thinking about pi over 3 right now. Okay, the reference angle is going to be pi over 3. Because, remember the values that we have memorized? The cosine of pi over 3 is 1/2. So the reference angle is pi over 3. So I encourage you to draw a little diagram to help you visualize what is happening. So we have 4 angles that have a reference angle of pi over 3. And they're these 4 angles. The cosine of any of them will be some kind of 1/2. But these two will be positive and these two will be negative because cosine is an x value. X values are negative to the left and positive to the right. For this particular problem, we want negative 1/2. So the solutions will be here and here. Okay, so that means we have 2 additional solutions. So q will equal, and this is going to be 2 pi over 3. And we have q is equal to 4 pi over 3. Okay, so we have solved for q. But in the original problem, we didn't have q, we had x's. So we need to solve for x. So just remember that innocent little substitution we did at the beginning. Q is really 2x. So I'm going to go back through and replace all my q's with 2x's. So that gives me 2x is equal to 0. 2x is equal to pi. 2x is equal to 2 pi over 3. And 2x is equal to 4 pi over 3. So I need to solve each of these little equations. So here I would be dividing by 2. Really, all of these I'm going to be dividing by 2. So I might as well just do this everywhere. Dividing by 2 everywhere. Look, when you divide a fraction by 2, you can just put it in the denominator. So here I'm dividing by 2. But when I divide a fraction by 2, I can just put it in the denominator. Okay, so that is going to give me x is equal to 0. X is equal to pi over 2. And over here I will have x is equal to, well, this will be 2 pi over 6, but that reduces to x is equal to pi over 3. Now I feel like I should put a box around this now. And over here, I will get x is equal to 4 pi over 6. But that will give me x is equal to 2 pi over 3. So these are the 4 actual solutions to the original equation. Okay, wow, that was really interesting. Okay, looking at problem number 10, we got the cosine 2x. So let's find cosine 2x. Oh God, there's 3 different versions. So we need to slow down and figure out which version we're going to use. Let's see. Looking at the rest of the problem, I see that we have sine squared. So let's pick the version that will give us sine. Let's pick this version. So here we go. We've got cosine 2x is equal to 1 minus 2 sine squared x. Okay, so I'm going to make that substitution right here. Alright, so this is going to give us 1 minus 2 sine squared x. Okay, now I'll just copy down the rest of the problem around it. So we have sine squared x, and then minus, and this is all equal to 1/2. It's important that you put this in parentheses because this negative sign needs to be distributed. Okay, think of it like a -1 that we have to multiply by everything. So that's why on the next step I will have sine squared x, but then I'll have minus 1 plus 2 sine squared x. Alright, interesting. So I have these like terms, sine squared x plus 2 sine squared x. It's like 1 sine squared x plus 2 sine squared x. So that's going to be 3 sine squared x. Minus 1 is equal to 1/2. So I'm going to add 1 to both sides like this. Alright, so now I'm going to have 3 sine squared x equals. But, okay, how do you add 1/2 plus 1? Remember, 1 is a magic number because 1 can be written as 2 over 2, 3 over 3, 4 over 4, etc. All of these are equal to 1. So, when it's time for like denominators, just choose your denominator and go for it. So I would like a denominator of 2. So I'm going to write this 1 as 2 over 2. Okay, so I've got 1/2 plus 2 halves. That is going to be 3 halves. Great, so now I need to divide both sides by 3. So I'm going to divide by 3 over here. When you divide a fraction by 3, you just put the 3 in the denominator. That's how you divide a fraction. You just put it in the denominator. Okay, so that's going to leave us with sine squared x is equal to 3 over 6. Okay, so now it's time for me to, okay, let's reduce that. So that'll be sine squared x is equal to 1/2. Now it's time to take the square root of both sides. Now be careful, because when you take the square root of both sides, you have to remember that the solution can be positive or negative. So I will have sine x is equal to plus or minus 1 over the square root of 2. Okay, and please understand, if I take the square root of 1/2, that's the same thing as square root of 1 over the square root of 2. And the square root of 1 is just 1. So that's how I got 1 over the square root of 2. Okay, erase, 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 erase. So now it's time to ask ourselves, the sine of what angle is equal to 1 over root 2? That's pi over 4. So that tells me that I've got a reference angle of pi over 4. Okay, so let's look at a diagram of pi over 4s. Alright, here's a diagram. Okay, so I have 4 angles that have a reference angle of pi over 4. Okay, it's just that, so the sine of any of these is going to give me 1 over root 2. It's just that these two will be positive and these two will be negative. Sine is a y value. It's positive high and negative down low. However, because of the plus or minus, we want all of these. All of these will be solutions. So I will have the following 4 solutions then. X is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So these are the 4 solutions to problem number 10. That's going to do it for this video. I hope it was helpful, and I will see you on the next video.
If you know how I feel, why would you say that? Why would you say that?